Okay, on 31, they're wanting us to show that this equation is equal. And what they're really trying to get you to do is get ready for the next section with this problem. If you look at log 2/8, if you kind of wrote that as, we're supposed to basically, they give us a hint, simplify this log, add them together, and see if it's equal to this one. So let's look at log 2/8. If I labeled that log A, B, C, let me just put a C here, 2 to the C power, I'm sorry, we would say I, C, a B, and your A is 2, and C is C, and B is this 8 here. 2 to what power is 8? Oh, that's 3. So what I could do is say, oh, well, that was equal to 3, okay? Now let's look at the next one. Log 2 to the 2 of 4 equals some number C. All right, so if we label that log A, B, C, I, C, a B, we'll write that down, and now we'll go put the numbers in. 2 to the C power is 4. Oh, 2 squared is 4, so C is 2 here. So this number is 2. And we know on the left side that 3 plus 2 is 5, but we have to go look at, let's go look at the this right-hand side and see if it's 5, because we know this should add up to 5 on the left-hand side. So we've got 3 plus 2 equal, and let's check it out. We're going to put a question mark here because we still got to see what's log 232. All right, if you label this log A, B, C, and rewrite it as I, C, a B, A is 2, put my C over here, C is the missing exponent, and B is 32. Oh, 2 to the 5th power is 32, so this is equal to 5. Does 3 plus 2 equal 5? Yes. Okay, now I want you to kind of notice what's going on here because they're trying to get you ready for the next section. If you had a log base 2 here and a log base 2 here and a log base 2 here, so one thing we notice is the log is always the same. And if you had a log 2 of 8 and a log 2 of 4, how does that relate to 32? You'd think you'd add the logs and have log 2 of 12 would be on the other side, but it's not. Notice these are multiplied to get 32 to be, and that's what made it come out to be equal. And that's because a log is an exponent, so if I've got exponents going on, I'm going to use exponent rules, okay? And it's not so important that maybe you really understand so much that you're using the exponent rules, but it helps explain why I wouldn't add 8 and 4 and have a 12 over here, but I would multiply 8 and 4 and get a 32. Okay, let's look at the B part. They say in B that we're supposed to show that log 9, 3 plus log 9, 27 is equal to log 9, 81. Notice again that you've got the same log on each one. It's a log base 9. And notice again you've got a 3 and a 27 on the left, and it's 81 on the right. And if you multiply 3 times 27, you get 81. Well, let's go check this out, okay? Let's label, we'll just use different colors again. Log 9, 3 is equal to some number C. So if I rewrite that as I, C, a B, I would have 9 to the C power is equal to 3. Well, how do you get 3 from 9 if you got an exponent involved? Wouldn't you square root 9 to get 3? Well, what does that mean? It could be the square root of 9 is 3, but how do I write a square root as a fractional exponent? Oh, it's a half. 9 to the 1/2 power is 3 because the square root of 9 is 3. So this number right here is going to be a half. And what we'll do is we'll just plug in and see that this works. And it should work because I know the rules they're trying to get you to learn here. All right, let's look at the second one. Log 9, 27. We'll put equals C. And again, we can label it A, B, C, and rewrite it as I, C, a B to try to figure it out. So A is 9, C is the missing exponent, and you get a 27 over here. All right, this is going to be a little harder to figure out. 9 and 27, you can't write 27 in terms of a 9 with an exponent on it right off the bat. But what we could do is we could rewrite both of these, 9 and 27, in terms of base 3, because 9 is 3 squared, so we'll replace 9 with 3 squared, and 27 could be replaced with 3 cubed. All right, we're still trying to figure out what that number is. So if you remember, if you have a power to a power, we can multiply. So we get 3 to the 2c power is equal to 3 to the third power. And if these two expressions are equal, and they've got the same base, that means the two exponents must be equal. So that would mean 2c equals 3. And if you divide both sides by 2, c would be 3/2. So let's go write that up here. Now I know that 1/2 plus 3/2 is 4/2, which is 2, right? Overall it's 2. Let's go check out this last one and see if it works. Is log 9 of 81 2? It is. If you have trouble seeing that, write log 981 is some missing exponent. And remember that what you're going to do is take the number on the left, raise it to the exponent on the right, and you should get the number in the middle. But again, if you need to, label it log A, B, C, and change it over to IC of B so you can think about it. A is 9, C is the missing exponent, and B is 81. 9 to what power is 81? Oh, it's 2. Does 2 equal 2? Yes, so this worked. So again, notice what they're doing is they're going to be able to combine this and say if you're adding two logs with the same base, then you can multiply the numbers and write it as one log over here. That's the rule we're going to learn in the next lesson, I think it's 10.5. Okay, so the generalization is if you have a log, and I'm going to write the rule that you're going to see. Let's say you have a log base A of some number U, okay? And you have a log, and it's in the same base, we'll just call the base A, of some number V. We can rewrite it as a log of base A, and what we can do is we can multiply the U and the V. That's the rule that we just saw, and it's the rule we're going to learn in the rest of Chapter 10 about properties of logarithms.